So, good morning, students. Today we are going to see about a single stub. Okay, single stub Smith chart sum. So here this is type 1. Okay. So what is meant by type 1 means simply they ask you to find what is the length. Okay. So what is the length of that? So now, so the given question where that is at L, which is 100 plus 121J, where Z not equal to 50 ohms. Okay, so characteristic impedance is 50 ohms, and the load impedance, or sometimes they will call it as a receiving end impedance also. So receiving end impedance. Okay. So now, as we all know that the first step, we have to find the normalized impedance. So we know that ZL by Z0. So by finding 100 plus 121J divided by 50, so this gives you the value of 2 plus 2.42J. So we know that, so the value is in a real plus imaginary, so it's going to be in upper quadrant. Okay, so let's move on to the graph. So here this is our given graph. The first step, we are supposed to draw 2.2 plus 2.4J. Okay, so here we are marking 2 plus 2.4J. As you all know that, so it can be performed by C. So from this point it will be your 2. So to dotted line, and in upper side you will be getting it as 2 point. So this is 2, 2.2, 2.4. So like that. So this will be our A. So our A is nothing but 2 plus 2.4 of J. Okay. So after marking, so this is our center as O. So OA as a radius. Okay. So first marking A in the graph, then followed by OA as a radius. We have to complete a circle. Okay, so in this sum you could see that the SWR value, so this almost comes as 5, so exactly this comes as 4.8. so here the SWR value is 5 4.8. It may depends. Some will get 4.9 or some will get around 5. Okay. So the SWR value is from 4.8 to 5. Then we are completing the circle, the rightmost value of the circle, we get it as a S. Okay, now we have to find the point B. Okay, so the first step is marking A, then the second step is marking O as a center. The third step is we are completing the circle and finding the SWR value. Okay, the fourth step is we are drawing a straight line which is directly opposite to the point A. So a line which passes through AO and it intersects the S circle which is directly opposite to A. That particular point is, we mark it as a B. Okay, so as you all know that for real value you supposed to trace it back to the center line here, and for the imaginary value you are supposed to trace it back to the outermost line. So from that you are marking, so this will be a B. So in this condition, so for the given sum the B value is 0.22, which is present in the bottom quadrant. You are supposed to put it as minus 0.26. Okay, so this will be your B value. Now we are going to find the C value. So this is our step 5. So by C value is nothing but you are moving the real value of A into 1. So that will be, so the point here is moved to here. It is by simply from, you could see a dark circle or line which intersects the S circle, which from the center O, which is nothing but 1.0. The real value is 1.0 at center O. So you are drawing a shaded line which crosses the intersects the SWR circle. So that point is C, and from where the imaginary value goes. So from where the imaginary value goes is 1.7. Okay, so the C value is 1 plus 1.7 ohms. Okay, so this is our step number 5. So after marking C, so from center of 0, C, from 0 to C, you are drawing a straight line, so which passes the outermost line with where the lambda will be 0.18 lambda. See, so this area is 0.18 lambda, so this area is 0.427 lambda, 0.0427. So this is the distance from the load. Okay, so this value can be found. So which is the distance of the stub from the load, LT. Okay, then in order to find LS, so by simply marking the point, imaginary point of, so this will be your 7th So sixth point is finding LT. So the 7 is 1.7. So the imaginary value of C is marked as E, which is in the bottom of the curve. So from O to E you are extending a straight line. So from where we are finding the difference. Okay. So here, which is our D, which is 0.25 lambda. So from the outermost line you are getting the wavelength as 0.334 lambda. So you are finding LS, which is length of the stub, which is 0.334 lambda minus of 0.25 lambda, which gives you 0.084 lambda. Okay. So in the given sum, they have given another data, which is the distance between load and first voltage minima. It can be found by simply multiplying that 0.2 into Z0 value, which is 0.2 into 50, which is 10 volts. Okay, where the first voltage distance between the load of first voltage maximum. So from the sum we have to find out as so in the given sum, see here, so we have found out as 0.084 lambda. So by multiplying 0.084 lambda, for lambda they have given us 2.5 centimeter, so it is going to be 0.10. So here the 0.084 into 2.5. So it can be calculated with the help of the calculator. So 0.084 into 2.5. So 0.0 into 2.5 meter. Okay. So if you get meter, you are getting it as 0.210 m. So which is here literally converted into centimeter as 210 centimeter. So that's all. Thank you.